Hello, sixth grade mathematicians. Here we are again today talking about something a little different. We're going to be talking about geometry. We're going to talk about shapes and review some things about shapes, some facts about shapes. But before we get started, there are a few things you're going to need. You're going to need scissors, tape, a ruler, the shape sheet that I gave you that you were to print off, and a pencil. So if you don't have those things ready yet, go ahead and pause the video and come back when you do. All right, so today we're going to look at these shapes, and there are just some things that I want to review about shapes, things that you need to know in order to move forward with this activity. So first of all, the first shape I have is a triangle, and you'll notice triangle, tri means three sides. But you'll notice that there's a square down in the bottom corner. And hopefully you remember that that means that it is a right angle. It's a 90-degree angle. So that is a right triangle. So that's one of the features with a right triangle. If you have a right triangle, you can always place the square to show that that's a square corner, meaning it's 90 degrees. All right, the next shape is also a triangle. And as you notice, there are no right angles, no 90-degree angles here. They're all less than 90 degrees. So right away, I can tell that this is an acute triangle. All of the angles are less than 90 degrees. All right, so the next shape is a parallelogram. And I know it's a parallelogram because the opposite sides are parallel. That's the only thing we can say about this shape. The opposite sides are parallel. So the top and bottom are parallel. If they go on and on forever in either direction, they'll never touch. And the sides are also parallel. If they go on and on in every direction, they will never touch. So that's the definition of a parallelogram. Then we have a rectangle. A rectangle also has the opposite sides are parallel, but it has an additional feature. All of the corners are square corners or 90-degree angles. All right, so a rectangle can be considered a parallelogram because by definition a parallelogram is opposite sides are parallel. So rectangles are also considered parallelograms. All right, and the last shape that we have is a trapezoid. And a trapezoid has one set of parallel sides, unlike the parallelogram, which are opposite sides are parallel. So here the top and bottom of the trapezoid are parallel. If they went on and on forever in every direction, in each direction, they would never touch. Now these sides, if we were to run our fingers up, eventually the sides would touch. And so those are not considered parallelogram. They would be considered intersecting lines. Okay, so that's just kind of a quick review of some of the shapes, some of the features of shapes, which is a part of geometry. Now, I also want to review quadrilaterals. So what is a quadrilateral? Well, quad is a prefix. Quad means four. If you think of a quad runner, if you've ever been on one of those quad runners, it has four wheels. So that would be considered, the quad would be considered four what? Four sides. So any figure that has four sides. So when we look up here, we have a few figures that have four sides, a few quadrilaterals. We have the parallelogram, we have the rectangle, and we have the trapezoid. There are some other quadrilaterals you should know. Square, and also a rhombus. So those are all quadrilaterals. All right, so that's just kind of a basic review of geometry. So we're going to be talking today about parallelograms, and we're going to determine the area of a parallelogram according to the information that we know about the area of a rectangle. All right, so I'm going to erase this, and I want you to think about the area of a rectangle and how we figure that, but I also want you to get your shape paper out and have that ready, and have all of your materials out and ready to go. So how did we figure the area of a rectangle? Well, the area of a rectangle, we multiplied the height times the base in order to get the area of a rectangle. So we're going to talk about and discover how do we figure the area of a parallelogram. So I've got some parallelograms here. I'm going to move my parallelograms up so we can see those better. Okay, so since we know the area of a rectangle, I want to know how can I relate the area of a rectangle to the area of a parallelogram? Is there any way that I can make this into a rectangle? Well, I think that I can draw a line here and cut off a piece of this, cut off a triangle or a right triangle from this, and move this as a puzzle piece over and create this into a rectangle. So I'm going to need to have my straight edge, and later on you're going to need a ruler to actually do some measuring. So if you don't have a ruler, it would be a little more difficult, but most people have a tape measure, or maybe you have a yardstick, so you could use either of those as measuring tools also. The tape measure might be a little more difficult. Okay, so if I were to draw this line and cut this and move this over to here, I could create a rectangle. Now, is this the only place where I can draw a line? No, I can also draw a line on the other side. So I don't want you to draw the line on both sides. I want you to choose one. All right, it'll make it more difficult if you draw it on both sides. So choose one. Okay, I could draw that here, and I could cut this and move it over here, and I could create a rectangle. So what I would like you to do is I would like you to choose one of the ways, draw it, and then you're going to cut that part off. Oh, wait a minute. I want to show you something first. Okay, so right now we have the height of the parallelogram. I want to go ahead and measure that right now because I want to determine when I cut this and I reposition this, is it the same height? Is it the same base? All right, so I want to determine this now, and I'm going to be measuring in inches, and I'm measuring this, and I'm noticing that this is 3. So for this, my height is 3. So my height is 3 inches. Now I need to measure my base. And I want to figure out what measurement is my base. And my base is 5 inches. So base equals 5 inches. All right, so now I'm going to make my cuts. I just wanted to do that because I want to compare this and make sure that what I am seeing is a consistency. So I'm going to cut this off. Notice I cut that from my parallelogram. And I'm going to place this as a puzzle piece over here to the side. And you notice now I have a rectangle. So I'm going to go ahead and take my tape. I'm going to tape it back together like a piece from a puzzle and put it back up here. All right, so now I want to measure this again and make sure that I don't have this totally lined up, and this is bothering me, I'm sorry. So there we go, that's a little bit better. All right, it was overlapping down here, it was bothering me. All right, so I'm going to go ahead and measure my base again, and my base is 5 inches, and my height is 3 inches. So it stayed the same. Even though I've repositioned things, I've noticed that it stayed the same. So if I know that in order to find the area I multiply base times height, all right? So I can find the area of that parallelogram. Even though I've deconstructed that parallelogram and made it into a rectangle, I have the original right here. So I know that 5 times 3 will give me the area of this parallelogram. So 15 inches. Now, what do we know about area? It's squared because it squares within the figure. So my area for this parallelogram is 15 inches squared, or I could go ahead and write 15 inches squared equals the area. Okay? All right, so base times height. Now, I have another parallelogram here that looks a little different. Now, as I'm looking at this parallelogram, I'm trying to find, is there any place where I can draw and take out a right triangle? Now let's see. Well, if I draw from here, I'm going to go down. Let's see here. Let me get this out. And I'm not really seeing a place because it goes off. See, if I tried right here, it's going to go off of the, So how am I going to do that? Well, with something that's oddly shaped like this, you'll notice what we did here, we repositioned. So if we kept it here, we could still do height times base this direction. So what I'm going to need to do with this figure is I'm going to need to add on, and I'm going to add on to this to give it the base and height. I've got to make sure that this lines up. Base and height. Okay, so I'm making this, I'm creating the height and the base out here to the side. So as I measure this, I'm going to be measuring in inches. I'm going to measure the base, and again, I've got the base is 3 inches. So my base for this parallelogram is 3 inches, and my height is 4 inches. Height is 4 inches. All right, so I've added on to the end of this, and just like I added on to the end of this in order to find the area. Now, there was no way for me to cut this. Now, I could have, if there was a way, I could have just put it upright and it would have been a rectangle. But what I had to do here is I had to go ahead and add on to the side this time in order to find the area. So area, remember, is base times height. So I've got 3 times 4, which will give me the area. And the area of this parallelogram is 12 inches squared. All right? So remember that a parallelogram can be deconstructed and made into a rectangle some of the time. Some of the time you're going to have to add on out to the side in order to get your base and your height in order to figure the area of the parallelogram. So what we're going to be doing, we're going to be going over some of these tomorrow, some in an exercise, and then I'm thinking about giving you a few of the problem set questions so that you can see whether or not you have any questions about this, or if you're okay with finding the area of a parallelogram. So we're going to continue this tomorrow. This was just an investigation to kind of get your feet wet and understand, and also to review some of the words. Also, something else I wanted to point out, because this is a word that's used quite frequently when talking about drawing these lines. This line, when I drew it over here, is perpendicular. Now, perpendicular means when you draw it from the top to the bottom, when it comes to the bottom and it intersects. So a perpendicular line is a line that intersects and creates a 90-degree angle. So I did see that in the directions coming up, so I wanted you to be familiar with that word, and I forgot to mention it earlier. So the word is perpendicular. Okay? It creates an intersecting line with a 90-degree angle. Okay, so perpendicular is going to be essential for you to know when coming up on some of the directions. So perpendicular, so say I've got, let me go ahead and draw what I mean by that so that you understand. So if I draw a line right here, this is perpendicular to the base. So I'm drawing a perpendicular line to the base. Again, over here, when we drew a line, we drew a perpendicular line to the top, okay? Because down here, it does not create a 90-degree angle. Up here, it does. And if we went, so there's a 90-degree angle. On this side, there's another 90-degree angle. So if we put them together, it's 180 degrees. All right? So perpendicular is a word that you're going to need to know coming up in the directions. If you have any questions, shoot me an email. If not, I will see you tomorrow, and we will go over some of the exercises that go into this in more depth. All right, see you tomorrow. Oh, wait a minute. Keep watching, keep thinking, and always stay curious. Now, see you tomorrow.